So our first fundamental theorem of calculus that we're going to go over, it's kind of strange, but it's also very important for some of the applications and some of the other proofs and things in calculus. But basically the idea is the derivative and the antiderivative cancel each other out. Who would have known, right? You know, if you take, if you do the derivative, so for example, we know that the antiderivative of 2x is x squared. So if we take the derivative of that, we just end up back at 2x. So this inverted operation idea kind of thing, if we take the antiderivative and then the derivative of that, we just end up back at where we started at. And that's exactly what's going on here. Now this gets a lot more complicated, as you'll see in the next video in the next section, which we'll save for the next section. But for the basic idea, if you run into the situation where your bound is some number on the bottom and x on the top, the derivative of the integral, you just replace whatever's a t or some other letter with x, and that's it. The derivative and integral, they cancel each other out because they're inverses of each other. The derivative and antiderivative, if you do both of them, they'll just cancel each other out. So it doesn't even, it doesn't even matter. Like, it can be something really crazy. The derivative, let's just say from -10 to x of t squared times the square root of tangent of the square root of t e to the t dt. It could be something crazy. We don't have to worry about evaluating this integral and this derivative, because since it's an integral sign and an antiderivative and derivative together like this, they cancel each other out. The x gets plugged in, so we end up with x squared square root tangent of the square root of x e to the x. And so very simple, right? It just cancels each other out and we're done. Yes, this assignment is that easy. I'm not lying. And when you run into an AP question like that, yes, that AP question is that easy. So don't let this confuse you. So right here, just a different way they're stating it. And that might be what confuses people. They're asking us to find g prime. Well, g is the antiderivative of this. So when we do the derivative of the antiderivative, it's just going to cancel out that sign. So let's start with g prime of x, and then we'll worry about the 9. So g prime of x, derivative of the antiderivative goes away. We plug in the x, so we end up with the square root of 2x plus 7. So g prime of 9 is a square root of 2 times 9 plus 7, which is the square root of 18 plus 7, which is square root of 25, which is 5. And there you have it. And the rest of them are like that. Here's g prime. Derivative and antiderivative cancel each other out. This is only when you're doing the derivative of the antiderivative, though. Don't start, thinking every single antiderivative is just simply plug it in, right? You're going to have to eventually learn how to find the antiderivative. But in this assignment, we're just learning that the derivative of the antiderivative, they're going to cancel each other out. So that's because we're doing the derivative of the antiderivative. That's why this is happening. Nothing too crazy here. And we'll go a little more into the details in the next section. Here it's, sine of pi, 0, easy. And that's it. That's that assignment.